Okay, here we are with harmonic motion day 1 homework number 2. And I've already drawn out my graph, done my A through E, and I've already read my problem once. I know we're talking about a river steamboat that has one of the big wheels that goes into the water and turns to push the steamboat along. So I figured out what the problem is about, and now I'm ready to actually put some numbers on my graph. The first thing I see as far as the numbers happens right here, and it tells me when the stopwatch is at 4, the point is at its highest value, and it's at 16 feet. So that's got to be my maximum number here is 16, and I know it's there at a time of 4 seconds. And then it tells me that the wheel's diameter is 18 feet, so that's got to be my highest, my lowest there. This has to be 18. And it tells me it completes a complete revolution every 10 seconds. Well, if I think about a wheel for a second, if I start at the top and I go all the way around one complete revolution, we're talking about going all the way back to the top. So that means it goes from the top down to the bottom and then back up to the top 10 seconds later. So from here to here has to be 10 seconds. 10 plus 4, that makes this 14. Now that I know that information, I can also fill in my other values here. If the whole thing is 18, that means this part and this part are each 9. So 16 minus 9 is 7, minus another 9 puts this at negative 2. Let's fill in some of our values here. Well, A, that's 9, we just said that. The middle one, that's D, that's 7. I know I start at 4, so that's C. And I know from here to there, what letter is that? That's our E, which is 10. I can find my increments. That's 10 divided by 4 is 2.5. So I can go along for each one of these and add 2.5. So that makes this 6.5, 9, and 11.5. I just used my calculator and added on 0.25 each time. I also know B happens to be 2 pi divided by what E is. I could reduce this if I wanted to pi over 5, but I can totally just use this number in my calculator. Either one will work just fine. Okay, if I look at my question parts, the first thing it says A was sketch the curve, so we just did that. B says, what's the lowest point that the water wheel goes? Well, it goes to, the lowest point is negative 2. Does that make sense in our problem? Well, we're talking about how far down the water wheel goes, and if you think about, you've got a boat with a water wheel on the back of it. Would it make sense that it's going down below the top of the water? If we call the water 0, it makes sense that it would go down below the water. So, yes, reasonable. 2 foot below water surface. If the paddle doesn't go into the water, it can't push the boat along. Okay, part C says write the equation. That should be easy because I already know all my information here. So y equals A. We know it's a cosine curve. 2 pi over 10 x minus 4 plus 7. D says, where is the water wheel at time 17? So I'm going to put in 17 for x or y. That's going to be our x. And I want to know my y value there. So now I'm ready to put this on my calculator. So I'm going to look at my calculator, go to the equation solver. I'm already in it. And I've already entered my values for A, B, C, and D. And I'm ready to put in my 17 for my X. And solve. And I have my 4.22. And can I check this on my graph the way my graph is now? No, because it doesn't go all the way to 17. So I'm going to go ahead and extend my graph a little bit and see where this is going to happen. I know my graph's going to come down like this. 14 plus another 2.5, that's 16.25. Go over another 2.5. Nope, 16.5. Go over another 2.5, that puts me at 19. So my 17 is going to happen right about here. If I look at my curve, does it appear that this height right here could be about 4 foot? It looks reasonable to us on our curve. Okay, E now says, what is the first point, positive value where T was at the water surface? So we have to kind of think what level here would be the water surface. Well, that would be where Y equals 0 feet. That's the water surface. So we're looking for, where does that happen? Well, it happens right here. If I put in a 0, here's my 0 line. It's going to happen right in here, somewhere right about there, and somewhere right about there. And it asks me for, where does it go into the water? That's the first part of part E. And where does it come out of the water, which is that part right there. So that's what we're looking for. So I'm going to put in 0 for Y. And then I'm going to look for, what is my X value? But I don't want it to look close to 17 over here, because that's not the first time it goes in the water. I want the first time over here. So I'm going to guess that it's close to 6.5. And then I'm going to do the solve. And it tells me it first happens at 7.9. Looking at my graph, 7.9, that seems perfectly reasonable. Now I also want to find where it comes out of the water, so I'm going to guess 11.5 and solve. And it says that it comes out a little bit less than that, about 10.08. And if I look at my graph, that's also in this interval, so that looks perfectly reasonable. So I'm going to write my answers down on my thing. Into water at T equals 7.9 seconds. Out of water at T equals 10.08 seconds. And we're done. Thank you.